So let's get started. All right, so this is the SIG Autoscaling introductory session. I'm Solly Ross, DirectX-Man 12 on GitHub.
And hello, I'm Marcin. I'm a tech lead of the Autoscaling team at Google, and also I act as a co-lead of SIG Autoscaling.
With me.
Okay, so there are various questions that people ask in their life. Some of them are trivial, like what should we eat today for lunch? Some of them are changing your life upside down, like will you marry me? Some of them are asked for just pure speculation, like who shot the Kennedy? Today we will focus on something much more profound, something that can be compared to the famous question of life, universe, and everything asked by Douglas Adams in his Hitchhiker's Guide to Galaxy. The question that my team asks itself every single day, which is, how much resources do you need in your cluster? Yeah, if you ask this question to developers, you will get various answers. You can get, I don't know, or it depends, or we need to run some more tests, or you can get a semi-random answer like 42, just like in Hitchhiker's Guide. This 42 number might be way too large, and probably the guy who said that overestimated the needs. Sometimes, if you are lucky, the developers run some tests. Sometimes these tests were based on the correct version of the application and rough impression of what the traffic would be. If you are lucky, these estimates might be quite accurate, but quite often they don't include the very important factor, the change. In the modern software engineering world, versions change all the time. Continuous delivery pipeline pushes the new versions of your applications over and over. The new version might either be faster than the previous one or introduce some performance regression that not necessarily might be caught in the tests. The traffic might change. Some real-world events may cause a sudden inflow of requests. The new launch feature may make the application much more popular. Miscommunication between various engineering teams may lead to inappropriate use of the API, and so on and so on. And these changes may cause you a lot of problems. Your application might become unresponsive, crash, and drop shame, grief, and serious embarrassment on you. Not to mention financial impacts on your company and on your personal career. You may have a superhero on your team, someone with special powers, full root access, unlimited budget on your cloud provider, a friendly Spider-Man from the neighborhood who will fix all of your resources and applications. However, he may save you once or twice, but superheroes get tired and of saving your butt over and over. They also want to have vacations, they want to have personal life, they want to have sick leaves, so you should not strongly depend on them. You need a robot that will take care of your cluster and your application day and night, someone that doesn't need vacation and doesn't get tired. A robot called autoscaling. The mission of this robot will be to automatically adjust resources to match the current needs. But what does it exactly mean? The first goal of autoscaling is to save you from this: a total catastrophe, crashing application, outages, unhandled requests, increased load, or performance impacting changes. The second goal of autoscaling is to save your money. Based on the first goal of autoscaling, you could just provide an insane amount of computational resources, pods and stuff, and call it a day. However, you don't want to pay an insane amount of money. You want to pay just enough for what you really need. So the ultimate goal of autoscaling is to keep the right balance between what you need to not to have your application crashing and what you really need in terms of spare capacity and resources. So let's focus on this problem, how to maintain the decent load in your application. You can think about pods and application as pipes. There is some water, traffic, coming in through the pipe. You don't want this pipe to explode due to high pressure or to be underutilized and thus be a wasted investment. And you can imagine that on every pipe you have this small meter with a gauge that shows some metrics. There are some values on the gauge that may indicate problems, like if the load is starting to be too high for the pipe or actually for the pod itself. For example, it may happen that the pod is using more CPU than it has originally requested. If the load goes above the safe threshold, it might be beneficial to start a new pod. Luckily, starting a new pod is much easier than laying a new pipe. Thanks to deployment, stateful set, starting a new pod is more like cutting a cookie with a cookie cutter. Let's take a look at the more concrete example. Let's imagine that this gauge shows the ratio between how much resources the pod really uses and what the pod has initially requested. So here we have 4 pods. Each of them is running really hot. They use 93% of their requested capacity. This is not a safe situation. If a sudden spike in the traffic comes, your application may not be able to handle this additional traffic and the whole application may become unresponsive. However, if we add one more pod and the traffic doesn't change, then this is quite likely that due to the construction of services in Kubernetes, the traffic will go to all nodes and to all pods equally. And in that way, the load on the other pods will go down. So it will go to the level of 70%, which is much safer than 90-something. In this, if the situation is different and your application is not using that much of the requested capacity, it might be actually beneficial to remove one pod and have a smaller deployment, less pod, and more resources in your cluster. In general, we want to specify a target, not too big and not too small, something that we would be happy with. Then the autoscaler will try to add or remove pods to move the load more towards the desired value. And that's what horizontal Pot Autoscaler does. Horizontal Pot Autoscaler is built into the core Kubernetes from quite a long time. It adjusts the number of replicas to maintain the target load. But what is the load exactly? For quite a long time, we considered the load as the ratio between what the pods are using in terms of CPU and what they have originally requested. Because the underlying monitoring infrastructure allowed us to do only this. So the architecture looked more or less like this. There was a heapster, which is now called metric server, that was scraping kubelets for the container metrics. And we created a horizontal Pot Autoscaler that was talking to heapster to get the CPU utilization data. And based on this data, to appropriately scale up and down deployments with pods. Okay, so we have CPU-based scaling. However, CPU utilization is not the only way to express the load. For some people, this metric is requests per second. For some people that run, for example, some batch processing job, the right metric is the queue size. For the others, who are more focused on SLOs, the right metrics would be the response latency. And for these reasons, we introduced custom metrics. With custom metrics, users are allowed to point horizontal Pot Autoscaler to some metrics that you have in your monitoring solution and scale based on it. On GKE, the metrics might be in Stackdriver, on some other cloud provider or on-prem in Prometheus or in something completely different. Okay, so it works like this. The pod on some other entity pushes a metric to a monitoring solution. Then we have horizontal pod autoscaler trying to get metrics through a dedicated custom metrics adapter from your monitoring solution. And based on that, the horizontal pod autoscaler controller adjusts the number of replicas in your deployment. Okay, how to use it? I said that horizontal pod autoscaler is controlled by the API object. That's true. So you can create an horizontal pod autoscaler, point it to a deployment, and configure a metrics for it. The metric can be CPU load or a custom metrics. You also need to specify a target value for the metrics, and you can also provide a couple of metrics if you want to base your autoscaling on multiple inputs. For CPU load, you can also use a dedicated kubectl autoscale entry for more convenience. But for custom metrics, you have to play with YAML files. When to use it? Horizontal pod autoscaler is best with stateless serving workloads. So workloads that can be easily started and killed. Things that don't have too much data, that don't need high initialization time, and workloads that can add or delete pods at will. You may base your scaling, as I said, on CPU load or some metrics, and we have a couple requirements for the metrics. The metric should be of a gauge type, so it should change in time up and down, and hopefully be quite responsive and react fast to the changes in the upcoming traffic. Horizontal pod autoscaler doesn't work with metrics like counts, or it doesn't work with histograms. So in order to properly use it, you need something that goes up and down. It's basically a histogram, like a speed in your car. Horizontal pod autoscaler is not best suited for stuff like stateful set, although with the appropriate care, it might be used to scale it if you really try it hard. There are two talks about horizontal pod autoscaling with custom metrics, so I will not give more details about it. I will give you pointers to these talks later in the presentation. So I showed you one way of dealing with the loads in your pods. Let's take a look at the other one. Okay, that's me. A couple days ago, I had a family event for which I needed to fit myself into a shirt, tie, and a suit. And I realized that, unfortunately, my shirt is too small for me. It would be very inconvenient for me to be in a small shirt, especially around the neck, and there would be a risk that the buttons will not hold the load and plug off and kill someone. Either way bad. So horizontal autoscaling was not an option. I couldn't get another replica of myself. I'm a singleton, basically. So in Kubernetes, we have similar situations. Some containers are either too small or too big to appropriately hold the content. And for this workloads, we have introduced vertical pod autoscaler. Vertical pod autoscaler adjusts container sizes based on the real-world usage. Let's take a look at this case. We have a similar pod than previously. It's consuming 95% of its resources. In horizontal pod autoscaler, we will add yet another pod in order to split the load between two. But as we said, it's not always possible. So in vertical pod autoscaler, we are doing another trick. We are increasing the pods, increasing its request, so that suddenly this 95% load becomes a much healthier 70% load. Vertical pod autoscaler architecture is quite simple. We have a recommender that provides recommendations about the sizes of the pod. We have an updater which looks at the pods and checks whether the current pods have the right request set, and if not, the updater kills these pods, and the killed pods are recreated by their controllers. They go through all of the admission plugins in API server, and in that admission chain, we have our own admission plugin that takes recommendations from the recommender and applies them to the newly created pods. Okay, so vertical pod autoscaler can run in 3 different modes. It can give you recommendations only, meaning that it will give you a hint about the proper size of your pods, and you will have to apply this hint manually at your convenience. It can apply the recommendation at the init time, which means that whenever you create a new pod, it will get the appropriate resources. However, the VPA will not touch the existing pods. Or you can trust it fully and go full speed with vertical pod autoscaler and turn on auto mode. In this mode, vertical pod autoscaler will check whether the currently running pods have the right request, and if not, it will update them, by unfortunately killing them. Okay, so how to use it? In a similar fashion as horizontal pod autoscaler, VPA is controlled by API object. Right now, as we are in alpha, where the API is based on custom resource definition, CRD. So you need to create a CRD with the appropriate data. This data include the label selector for pods which you want to autoscale. You need also to specify what mode you would like VPA to operate in, and possibly some extra data for deciding which containers should be updated by VPA. You can also provide minimum and maximum amount of CPU and memory that VPA should give to your containers. More details about vertical pod autoscaler are available on our GitHub page under this link. When to use it? VPA is suitable whenever horizontal pod autoscaler is not suitable. So it can scale workloads for which you need to have a fixed amount of pods. For example, your stateful set, or workloads that have just a single pod, and workloads that you cannot basically, to which you cannot basically add more pods. Okay. Can you mix horizontal pod autoscaler and vertical pod autoscaler? Well, not really, not yet, and not always. Horizontal pod autoscaler and vertical pod autoscaler kind of try to solve the exact same problem. So how to deal with high load on your pod, how to deal with situation when the load on your pod is not so big and the requested resources are simply too big and your money is wasted. So when you apply both of them, they may cause your workloads to scale up too much or scale down too much. In both cases, it's a little bit dangerous. You can, however, try to combine horizontal pod autoscaler with custom metrics with vertical pod autoscaler. It's a bit safer, but it needs extra consideration and should be investigated or on a per case basis. Hopefully, we'll have a better story about this in the future. Okay, so you have either a couple of extra pods or some bigger pods, and now you suddenly realize that actually you don't have that much space in your cluster to hold all of these extra pods. What now? Is it like a dead end? No. You run on a cloud, and cloud can be considered as a huge ship. What you need to do now is to get some extra capacity at the right time and release this capacity when you don't need it anymore. This brings us to the very, very important point in SIG Autoscaling agenda. We want to automatically ensure that you have enough capacity in your cluster. But what exactly is the right capacity? So, simplifying a bit, Kubernetes scheduler schedules pods based on their declared usage. For example, on this picture, we have 4 nodes. 3 of them are quite busy. 1 node has just a small pulse, and it's quite likely that this green one will fit into the 3rd node, like here. However, if there is no space left in the cluster and all nodes are busy, then the only option is to add yet another node. And when the node arrives, scheduler will reconsider this green pod and possibly put it on the newly added node. If the situation is different and not all nodes in the cluster are well utilized, for example here we have only a small pod running on node number 3 and a small pod running on node number 5, we could move the green pod to the 3rd node, freeing 5th node and making it available for deletion. And that's exactly what Cluster Autoscaler does. So Cluster Autoscaler has 2 points on its mission. Whenever Cluster Autoscaler sees a pending pod, it checks whether it would help if it added yet another node to your cluster. If this evaluation is positive, it talks to your cloud provider and buys you a new node. And when the node finally arrives, scheduler re-evaluates the pod and puts the pending pod on the newly added node. In the same time, Cluster Autoscaler constantly monitors your nodes, and whenever your nodes are not that much utilized, it looks deeper into these nodes. It considers what would happen if the node was removed, whether all the pods that are there would be able to schedule elsewhere. Would there be any impact to important system components like DNS or Hipster? Would it violate some of the pod disruption budget? And if the answer is negative for all of these questions, and it is safe to remove the node, and the node is unneeded for an extensive period of time, I mean about 10 minutes, then the node is removed, reducing your monthly bill on your cloud provider. There is an important distinction between Cluster Autoscaler and horizontal and vertical Pot Autoscaler. Cluster Autoscaler is based on scheduler. So it's based on pod constraints, it's based on the Kubernetes internals, like pod disruption budgets and system components, and it doesn't take into account, for example, what is the exact load on your nodes. So if your nodes are burning hot, but your pods have wrong requests, it will not help you. Helping you is the mission of horizontal and vertical Pot Autoscaler. They are there for making your requests right, or making the load spread across more pods than you originally have. Okay, so how to use Cluster Autoscaler? On GKE we have a single command that will start everything for you. On other cloud providers you need to execute a couple of manual kubectl actions, but everything is documented here, so it should also be quite easy for you to set up the thing. We have a support for Google Cloud, Azure, and AWS. When to use it? Always. Unless you don't want your cluster to be scaled, or you don't want to have like a changing bills, but most of big clusters are running Cluster Autoscaler right now, and they say that it's a good choice for them. Or you cannot run cluster autoscaler if obviously your cloud provider is not supported. Okay, so now is the time for a little bit of status report. Where are we with all of these efforts? Cluster Autoscaler is in GI since September 2017. It scales more or less to 1,000 nodes and supports 30,000 pods. It can go further, however, with a slower response rate. Horizontal Pot Autoscaler is in GA. I mean, the horizontal Pot Autoscaler based on a CPU load. Custom metrics are currently in beta. Vertical Pot Autoscaler is in alpha. We launched it in late March and we'll hopefully be pushing it more towards beta sometime this year. So what is missing there? In Vertical Pot Autoscaler, we hope that all problems with your request will be automatically solved. And one of these problems can be out-of-memory errors that can happen on your nodes. Unfortunately, the current support in kernel and in kubelet is not sufficient. We don't have the right reporting. We don't have the appropriate logic in the kernel killer to do reporting and handling appropriately. This needs to be fixed. Moreover, currently it is not possible to update pod requests without actually killing it. So even if you have enough capacity on your node to increase the pod, you need to kill it so that the Kubernetes god is satisfied. Eventually, we hope to have this in-place upgrades in place, so you will have a much smoother ride with Vertical Pot Autoscaler. Horizontal Pot Autoscaler could possibly be more configurable. We have a lot of hard-coded constraints that we are hoping to get rid of. And currently, custom metrics are supported only on for two monitoring solutions, namely Stackdriver and Prometheus. We would. Oh, it's further? Oh, okay, okay.
There is support for SysTig, I believe, released a adapter. I think it's currently closed source, unless there's any SysTig people in the room that can clarify. But they posted a blog post about it. Oops, sorry about that. There's actually an adapter for SysTig now. I believe it's closed source at the moment, although someone from SysTig can probably clarify. But they posted a blog post about it, and if you Google for it, you should be able to find it.
Okay, I didn't know it. That's great. But if there are any monitoring solution employees around here, please, please, please get your monitoring solution integrated with Horizontal Pot Autoscaler.
You can come up and ask me for details about how to get started about that later. And there's some helper repositories around that should make your life easier.
And what else? There are dedicated autoscaler for system components. KubeDNS has one, Hipster has one, and ideally we would like these autoscalers to be unified under Horizontal Pod Autoscaler and Vertical Pod Autoscaler umbrella. Okay, this talk is slowly getting to an end, so I would like to give you a little bit more details about our SIG. So, yeah, we'll do it. We have meetings every Monday at 4 p.m. Copenhagen time on Zoom. We have a quite active Slack channel. And most of our staff sits in Kubernetes /Autoscaler repository on GitHub. And there are other autoscaling related talks on this KubeCon. There is Autoscale your Kubernetes workload with Prometheus at 11:10 tomorrow. Horizontal Pod Autoscaler Reloaded scale on custom metrics at 4:35 also tomorrow. And SIG Autoscaling deep dive on Friday at 4:25 p.m. Thank you. And now is the right time for questions.
Anybody have any questions?
Yes. Can you run with my...
With the horizontal pod autoscaler, do you notice if like you are increasing the number of pods, but it doesn't help. Like that would mean that it continues increasing and increasing, right? Do you notice this situation?
Yeah, so right now, we expect that your metric will have to react to that. So if you use a metric that doesn't react to a change in pod count, then it will keep scaling until you hit the limit. So in the horizontal pod autoscaler object, you can set a maximum and minimum number of pods, and it'll keep its scale between those pods. But if your metric does not change right now, it'll keep attempting to scale as long as it thinks it is allowed to. So this is a very important point of the horizontal pod autoscaler. Make sure you have a metric that reacts with your pods.
Thank you for the talk first. Yeah, I have a question because I've been reading about the cluster autoscaler and also the Odwinson test. And I saw that there's like different configurations running in the master or running in the workers. So what is the pro and the cons to run in some way on the other?
So in GKE we run cluster autoscaler and master because we take care of the masters and we heavily monitor it. So from our point of view, it's better to run your cluster autoscaler in such a way that it's always available. On GKE, we make sure that master nodes are available. If you think that your nodes are more robust and more resilient than your master node, then you can run it on the worker nodes. However, in most cases, master nodes are really well hardened, and for that reasons, probably it's better to run it on master. Okay.
Hey, thanks guys. Does the vertical pod autoscaler play nicely with jobs, perhaps in recommender mode? So if I'm sending jobs in, can I get some numbers out that, hey, these jobs are failing because they're out of memory?
Yes, to some extent. Vertical pod autoscaler doesn't have a reference pointer. It uses a label selector. So you can select arbitrary set of pods. So if you want to scale vertically your jobs, you can do so by putting the appropriate label selector there. Anything more? Anyone?
How do you go about actually kind of identifying appropriate limits to set on your containers or on your pods to start with?
How do you identify?
Yeah, so I mean, with the vertical pod autoscaler in recommender mode, cool, that's fine, but you're working with a set number of pods there. So the recommendation there may not actually be that helpful, I guess, if you're trying to scale outwards. So how do you determine the optimum resource level to request for your pods to, like, at the outset?
Okay, so how vertical pod autoscaler works is that at the very beginning, when it has no data, it doesn't do any actions. In time, when it gathers more data, it has more confidence what the appropriate request should be. So in vertical pod autoscaler, we have a field for status. The status contains three numbers. The one is the desired value for a particular resource, for example, CPU and memory. The other two values are minimum and maximum values that are still okayish. So we start with very small minimum and very small maximum, and in time we are reducing these values. And updater, when it sees that some pods are not within these values, kill these pods. So only after we get enough confidence that they have wrong requests, they are killed. At the very beginning, when we have no data, it's quite likely that we will not make any decisions. We will make some decisions when we notice that due to initial recommendation of, for example, due to what you put initially in your pod. The pods are umming, so they are using much more memory than you thought. So then we will react really, really fast and increase it. Anyone else? No? Then I would like to thank you for coming and see you on the other autoscaling sessions.